Hey guys, welcome back. It's me, Coach Sharf. Hope y'all are doing good. So this is part 4 of the practice test. It is problems 34 through 44. I'm actually going to go back and do one of the problems from yesterday, problem number 29, the one about the drinking cup where you're trying to get the surface area of the cone. I'm going to start with that one real quick and then try to get through the other ones as quickly as possible. At the end of the video, I'm going to talk about a couple things. I'm going to delay the rest of the problems on this packet in the next video until Monday, so y'all can try to have a relaxing weekend. I'm also going to try to do an Instagram live on Monday morning to hopefully clarify some things, answer any questions y'all have, and maybe just check in on y'all. So let's get to these problems first, and then I'll talk about that. All right. So here's 29. This one we looked at yesterday. So what you could really do with the surface area of the cone, if you actually cut it down the side and were to unroll it, all you would make would be a triangle, okay? So you just make a triangle, all right? The 4 inches, when you unrolled it, would actually be the height coming right down the middle, okay? The 3 inches going across the diameter, if y'all think about it, when you unrolled the paper cup, this is the base of the triangle, but it's also going to be the lip going all the way around the cup. So that length is actually the circumference of the circle going all the way around, okay? So what we're given, let me come back to it, what we're given is the diameter, not the radius. We're given the diameter, but we know the circumference, it could be 2 pi r, but it can also just be pi times the diameter. So my circumference is 3 pi, so that is this length, okay? So we're just getting the area of a triangle now, okay? 1/2 base times height. So I've got 1/2 times 3 pi times 4. If you want to take half of 4, you can do that. So it's just 2 times 3 pi. So let me punch that in the calculator. All right, I already got it in the calculator right there. 2 times 3 pi, which is 18.85, which we will round up to 19. So that is B. So there's that one from yesterday that I skipped. All right. Moving on to today's problem, starting at 34. All right. 34 is a transformation, particularly a rotation. Triangle XYZ is rotated 90 degrees clockwise about the origin. What are the coordinates of Y prime? So if y'all remember, I gave y'all a little half sheet that kind of summarized all of the transformations. I actually don't have it saved in my computer on my flash drive, but I found something similar. If you do not have that half sheet or do not remember this, I could post this because this is about close enough. All right, so it's got your different reflections. Over the x-axis, you can change the sign on y. Over the y-axis, you change the sign on x. Over the line y equals x, that's that diagonal line with a slope of +1. You just flip x and y. And here's your rotations. 180 clockwise or counterclockwise is the same. 90 counterclockwise, if you remember, if you think about it, 90 counterclockwise is the same as 270 clockwise. Same down here. 270 counterclockwise is the same as 90 clockwise. So that's the one that we want. So we're going to take our original xy. We're going to flip the numbers to get y and x, and then we're going to change the sign on what is now our second number, what used to be the first number, to the opposite sign. If we go back and look, our original y is at 1, 2, 3, -1, -2. All right. So we are at 3, -2. So we're going to flip y and x. So I got -2, 3. Then I make that number now the opposite sign. So I make it negative. So it goes to -2, -3, which is answer choice C. All right. 35. A triangle is dilated by a scale factor of 1/3, so it's made smaller. All the sides are 1/3 the length of the original. Which of the following best describes the relationship between the perimeter of the original triangle compared to the perimeter of the new triangle? So looking at these answer choices, you can go ahead and knock out B and D, because it says the perimeter gets bigger on both of them. Obviously, if my sides are getting shorter, my perimeter is not getting bigger. So you're down to A and C. Okay, I talked about this a little bit with the volume. So when you dilate all your sides, make them longer or shorter. If you're just talking about perimeter, perimeter's going to dilate by the same amount. If it was area, you got to square whatever the scale factor is. If it was volume, you'd have to cube it. So since it's just perimeter, it's just going to stay the same scale factor, which is 1/3, so it's A. If you really don't trust it and want to draw it out, or if you can't think of it the way I just said it, if you don't remember that rule, okay, draw a triangle. I know it's a little bit of a crooked triangle. Y'all deal with it. So 6, 6, 6. Those are my 3 side lengths, all right? If I make a smaller triangle, again, I'm looking at this through the lens of my camera, so it's a little crooked. Make all my sides 2, 2, 2. Got a couple equilateral triangles, okay? Add those up, I get 18. Add those up, I get 6. 6 is 1/3 of 18. So my answer choice is A. All right. 36. Find the surface area of the prism below. So, again, all surface area is, I get the area of all the different faces. Okay? I'm not getting the volume inside, it's still area. So I got to get the volume of this triangle in front, this triangle in back, and the 3 rectangles here on the right, here on the bottom, and here on kind of behind on the left. Okay? So I can get this rectangle 10 times 5. I can get this rectangle on the back 6 times 5. The 5 would be going across there. I don't know this one though, because there's a length here I don't know, which I have to multiply by 5. And for my triangles, this side would also be the height, because it's a right triangle. Okay, that would be the height. 6 would be my base. So I'd have to figure out that height as well. It's a right triangle, which means since I have 2 sides, I can use the Pythagorean formula. 6 is 1 leg, so 6 squared, plus the empty side is my other leg, so b squared equals my hypotenuse, which is 10, so 10 squared. So there we go, there's my Pythagorean theorem. So it's going to give me 36 plus b squared equals 100. Subtract 36 from both sides. B squared is 64. So B is 8. So this missing side right here would be 8. So what that's going to give me is 2 triangles with a base of 6 and a height of 8. Okay? So I've got 1/2. 6 times 8. So that's 1 triangle. 1/2. 6 times 8 for the other triangle. Then for my 3 rectangles, I got 10 times 5 on the bottom. 6 times 5 on the back, because it's this 6 going up and the 5, the dotted 5 right there. And then 8 times 5. 8 coming down this way and that 5. So I've got 10 times 5, 6 times 5, and 8 times 5. All right. So I've got 6 times 8, which is 48. Half of that is 24. 24 again. That adds up to be a whole. That would be a whole rectangle if I put them together. So that's 48. 10 times 5 is 50, which gives me 98. 6 times, it's a 5, not an 8. I know it kind of looks a little sloppy, a little far away. 6 times 5 is 30. So that'd be 128. And then 8 times 5 is 40, which would be 168 if you add it all up, which is C. So that is my answer, 168 units squared. Didn't tell us inches or centimeters or whatever, so we just say units squared. All right. 37, more right triangle trig. So there's my triangle. I'm going to try to keep this one short and sweet. Again, y'all can draw this one out if you want to. This is my angle of reference. 18 is my hypotenuse. X is the opposite side. The blank side is adjacent. So I got to use opposite x. And 18 is the hypotenuse, so I'm using sine. So sine of 25 equals opposite, which is x, over 18. Here we go. So this one, unlike the one where we had this yesterday, x was in the denominator and had number in the numerator. Now x is in the numerator, my number's in the denominator. So this is the one I could just throw 18 out here in front, okay? So 18 sine 25 equals x. You can just punch it in the calculator, which will give you, let's see here. Trying to punch this in the calculator looking through the camera, not as easy as you think. 18 sine 25 equals 7.6, which is A. 7.6. Here we go. There we go. All right. 38. What is the measure of angle 1? So this kind of looks like one of the ones we did yesterday. Okay, I got two parallel lines that actually have two transversals, right? So if you look at this transversal, 38 and this angle, this whole angle, so let me draw it out. Give me just a second. All right. So there we go. 38 and that angle have to add up to 180, right? So 180 minus 38 is 142 degrees, right? Okay. 142 degrees. However, we've got this one ray, extra ray, well, it's really another extra line, so we could draw that, but it's telling us that this angle is 76, okay? So this whole thing was 142. Now I'm taking away 76, which if I subtract that will give me 66. So that's telling me this angle is 66, okay? Now if you go and look, if you take out the parallel line coming across, you have the two transversals that cross, and they just form a pair of vertical angles, okay? So our angle that we said was 66 and 1 are vertical angles to each other. So let's see here, so we can get it focused. Lost focus for a second, there we go. So the other angle is 66 right here. And then 1 is vertical to that, so it would be 66, so that is D. All right, where's my cursor? There we go. All right, moving on. 39. What is the correct order of angle measures of the triangle from smallest to largest? Again, something we didn't really talk about. We didn't really cover. I don't know if y'all have seen it in a previous math class or not, but it's almost common sense, okay? So you got your three sides, okay? The smaller the angle opening is here, by the time it gets to the ends here, the less distance it's going to take to connect A and C. So shorter angle is going to require less distance. In a triangle, we know, of course, unless there's an isosceles or an equilateral triangle, if we have a scalene triangle, there's three angles, short one, middle one, and a big one. We can get that by getting what's ever opposite from the shortest, middle, and longest sides. B is opposite of the shortest side, so that's going to be my smallest angle. C is opposite of 4.5, so that's going to be in the middle. And then A is my biggest angle because it's opposite of 6.5, so that's going to be answer choice A. Okay? All right, 40. What is the equation of a circle that has a center -6, 2, and a radius of the square root of 106? So again, equation of a circle. We saw one earlier on this. As I told y'all, that was going to be the next thing we were supposed to get to, although I think I was going to skip it and just try to touch on it as we were reviewing. So x minus h squared plus y minus k squared equals r squared. H is my x coordinate, k is my y coordinate. Since they both have the negative signs in the formula, that means whatever the original number is, I have to take the opposite sign. And then what's going to be on the right-hand side is the radius squared. So let's start with the radius. If I square the square root of 106, the square and the square root cancel, so my right-hand side is going to be 106. So that automatically gets me down to C and D, and now it's just a matter of your signs. Since the center is -6, +2, I got to flip them to give me 6, -2. So my answer would be D. X plus 6 squared plus y minus 2 squared equals 106. All right. 41, a similar idea to what we just talked about on 39. All right. Guy and his dad are preparing to go sailing. The two diagrams show the boat's mast in different positions. Notice the length of the mast and the distance from the bottom of the mast to the winch are the same in each diagram. So that's the dotted line, okay? Which of the following best describes the relationship of the cable from the top of the mast in both diagrams 1 and 2? So the cable is the one on the right. Okay, so again, same idea I was just talking about on the previous problem. The bigger the angle, the longer that distance has to be. So on diagram 1, the cable is going to be longer than it is on diagram 2. So that is answer choice B. All right, 42, 3 more real quick. Again, this goes back to something I just talked about as well. Aaron collects snow globes. They come in cube-shaped boxes. So the small one is a cube, every side is 4 inches. The big one is a cube, every side is 12 inches. How does the volume change in the length of the sides from the smaller cube to the larger cube affect the volume? So our original box was 4 inches. This box is 12 inches, so each side is 3 times as long. So that's what I was talking about. It's a dilation by a scale factor of 3. But since it's volume, I got to cube it. 3 cubed is 27, so it would be B. Again, if you're not going to remember that, if you want to do the math, just do the math for volume. Length times width times height. So 4 times 4 times 4, which would be 64 cubic inches for the smaller box. And then 12 times 12 times 12, which I believe would be 1,768. 288, 1440, 1,728, I'm sorry, 1,728. But if you multiply 64 times 27 or divide 1728 by 64, you would get 27. If you multiplied 64 times 27, you would get that. If you divide that by 27, you get 60, or if you divide that by 64, you get 27. So your answer is 27. B. All right, 43. Which of the following correctly shows the number of faces, edges, and vertices of the triangular prism below? I know this keeps going blurry a little bit. I'm trying to fix it, guys. All right. So, again, we saw a vertice problem earlier, okay? So there's 6 vertices, all right? V, P, H, K, R, S. So there's 6 vertices. There's 5 faces, the triangle on the front, the triangle on the back. This triangle, this rectangle right here on the side, the rectangle on the ground, and then the rectangle on the back. So there's 5 faces and edges. Just the number of lines that makes up the shape. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got 5 faces, 9 edges, 6 vertices. Answer choice is B. All right, last one. Which represents the faces of an icosahedron? Again, I mentioned this word a couple times throughout the year because I told y'all they like to use it on the EOC for whatever reason. An icosahedron is an icosahedron is going to be 20 triangles, but an icosagon is a 20-sided polygon. Okay? Ico means 20. That's the prefix. So that's going to be D, 20. All right? Okay. So there's your problems for today. Again, a few of y'all submitted them. If you didn't, you still need to copy down the work. We're in a lot of work for many of these today, so not too bad, particularly those last 2. So this is what I'm going to do. So y'all don't got, if y'all went ahead and started working on the last of the problems, great. If not, if you want to, by all means go ahead, but y'all kind of take a break. I know y'all have been working hard in all your classes, hopefully. So if you haven't done the last 11 problems yet, y'all can kind of take a break, work on Monday during the day. I'll post the last 11 videos Monday night. Last 11 problems in a video on Monday night. Let me correct myself. But the other thing I'm going to try to do, and I'm sending this out over Mind as well, is I'm going to try to do an Instagram live on Monday. So the first thing I'm going to ask y'all is what time y'all would prefer. Maybe I can do a couple. If there's some of y'all that prefer morning, some of y'all would do afternoon. Try to start with that. Might evolve eventually into using Zoom. I think some teachers are trying that, or Google Hangout or something like that. But we'll start with Instagram Live just to kind of update y'all. Y'all can log in, ask questions. I'll try to, again, I think there's been a lot of questions about the work. I've tried to be clear in the messages I sent. Maybe I can clarify it a little more during then as well. So the Instagram is going to be Coach Scharf Math. Okay, just like the YouTube channel. So Coach Scharf Math, y'all look that up on Instagram. I'll send it out over Mind. Y'all can go ahead and follow that. And I'll be reaching out to y'all, see what time y'all would prefer to do an Instagram Live. So that's what we're going to do on Monday. So other than that, I think it's supposed to be good weather outside. It was supposed to rain most of the week. I don't really think it did, except a couple spurts here and there. Been pretty good weather the last couple of days. I think it's supposed to be tomorrow as well. So even in isolation, y'all get out in the backyard, go for a walk. Go, if you got a bike, go take your bike out. Just, enjoy this time. Use the weekend to relax, refresh your gear, and get back to work on Monday. So until then, y'all have a good weekend. Stay safe. I hope everybody's doing well, and I'll see y'all Monday. Bye.